Start now.
Good afternoon all. So today I am going to discuss about the kinetics and dynamics of rigid body. So let's first summarize whatever we have studied so far. So far we have studied about the kinetics and dynamics of point particle, and we have learned many concepts to describe the point dynamics and kinetics of point particle. So let's summarize some concept. First of all, we study kinetics of point particle. For that, we study reference frame, position vector, displacement, velocity, and acceleration, and we also discuss about the concept of relative motion. Then we have also studied about dynamics of point particle. So, like first law, second law, and third law of Newton's. We also define the pseudo force. We have also studied about the inertial frame and non-inertial frame, laws of friction. We have studied about the circular motion, dynamics of circular motion, and we have also defined some angular vector, we can say axial vector, while studying the circular motion, like angular displacement, angular velocity, angular acceleration, and we have also discussed about the linear velocity in the circular motion, tangential acceleration, and centripetal acceleration. We have also discussed about the linear momentum of point particle, means quantity of motion, and we also discussed about the momentum and external force applied to that point particle, relation between external force and linear momentum, and we have also discussed about conservation of linear momentum. We know about concept of center of mass, motion of center of mass, linear momentum of center of mass. So whatever concept we have studied so far about the point particle, now I will apply all these concepts to describe the dynamics and kinetics of rigid body. So now let's discuss what is the rigid body. Let's figure out what is the rigid body. This is the rigid body. One thing, actually body is not perfectly rigid, but for our convenient we assume all body is rigid to describe the dynamics of rigid body. Actually, constant particle of rigid body always oscillate about the main position, but we ignore this to describe the dynamics. So let's define rigid body. Distance between 2 points of the rigid body always remain fixed. Let this is a rigid body, point A and point B. These are the 2 points of rigid body, and D is the distance between point A and point B of the rigid body. Then this distance always remains constant even after application of the external force. So distance between 2 constant point of rigid body always remain fixed even if application of external force. Second one, relative velocity of approach along the line joining two particles remains zero. Let's VA is the velocity of point A and B is the velocity of point B, and BB make angle beta with the line joining particle, and VA make angle alpha with the line joining point A and B. Then VA cos alpha is equal to VB cos beta. Always. And now we can define the angular velocity of point A with respect to point B and angular velocity of point B with respect to point B. Let's VA sin alpha and VB sin beta are the perpendicular component of velocity of particle A and particle B respectively. Then angular velocity of point B with respect to point A is equal to relative velocity of B with respect to A divided by R perpendicular. Means VB sin beta minus VA sin alpha divided by R perpendicular, and omega AB angular velocity of point A with respect to B is equal to relative velocity of A with respect to B divided by R perpendicular. VA sin alpha minus VB sin beta divided by R perpendicular. So now I will describe the type of motion of rigid body. Type of motion. So first one is pure translational motion. Means omega is equal to 0. In this motion, each and every particle of the rigid body will cover the equal displacement in the same direction, and also each and every particle, velocity of each and every particle of the rigid body will be same, that is the same as the center of mass. This is the rigid body, and this is the center of mass. This is the point A, point B, then and this is the same rigid body after displacement. Point A, center of mass, point B. Then every point A, point B and point C, all points move in the same direction, that is parallel to each other. And also velocity of each particle will be same, as that is the same as the center of mass. Is velocity of A is equal to velocity of B is equal to velocity of center of mass. Yeah, we can say in the other way, lines joining any two particles of the rigid body always remain parallel when rigid body translate. This is the line joining point A and B. So after the translation of rigid body this to this, line joining AB parallel to A dash B dash always. Means in pivot translational all particles follow rectilinear motion. In translational motion all particles of rigid body follow rectilinear motion. Now translational motion. Rotational motion. In the rotational motion, all points of rigid body follow circular path except fixed point about which body is rotating. This is the rigid body. This is the axis AB about which this body is following a rotational motion. Then point this, get A, B, C. These are the points. All points follow circular motion with the same angular velocity except the point on the axis even linear velocity of point A, point B and point C will be different, but omega of the all point will be same. Means omega A is equal to omega B is equal to omega C. VA is equal to naught VB is equal to naught VC. VA, VB and VC are the linear velocity of point A, point B and point C. And on the axis omega is equal to 0, V is equal to 0. Second one, perpendicular distance of all constituent particle of the rigid body from the foot of the axis will always remain fixed. First one, all particles follow circular path with same angular velocity omega except the point lies on axis. Second one, perpendicular distance of all point from the foot of axis always remain fixed. During the whole rotational motion. Let's RA, RB and RC are perpendicular distance of point ABC from the foot of axis, then R perpendicular A constant, R perpendicular B fixed, R perpendicular C fixed. During the whole rotational motion. Next one is combined motion. Yeah, planar motion. Combined motion. Yeah, motion. So it is the combination of translational motion and circular motion. It is combination of translational motion and motion means each and every point of rigid body will follow circular motion about the fixed point या axis that lies inside the body या outside the body, as well as that fixed point axis will follow a translational motion with respect to some different reference frame. This is the axis and this is the disc. This disc is rotating about the axis with the angular velocity omega. And this axis is translating with respect to this frame, with respect to this point. So now figure out the combined motion of any point of this disc with respect to omega, with respect to this point. So if this is the perpendicular distance of this point P, then due to the angular motion या rotational motion, linear velocity of this point will be r omega, and let's axis is moving with respect to v, that is equal to VCM. So we know from the translational motion, if v is the velocity of rigid body, then every point of the rigid body will follow the same velocity. Then for the translational motion, velocity of this point will be v, that is equal to VCM. Then the net velocity of this point with respect to origin is velocity of this point with respect to point lies on the axis, then we can say with respect to center of mass r omega plus velocity of center of mass with respect to point O. These are the type of motion of a rigid body. Now I will describe about the dynamics of rigid body.